Hi everyone, and welcome to this new episode of the Active Directory Exploitation series. In this episode, we continue our discussion on Kerberos, and we showcase one particular class of attacks, which is known as the roasting attacks on Kerberos. Now, these are two specific attacks, which are the ASREP roasting attack and the Kerberoasting attack. In the video, we will provide a conceptual overview over these attacks, and as always, we will provide a proof of concept to show in practice how it works. As always, I hope the video is useful. I hope you get something out of it. If you do, subscribe to the XStamp channel to support and share this video with like-minded people. Thank you very much and enjoy the video. Now, these two attacks, ASREP roasting and Kerberoasting, are very similar. This is why I want to introduce what is the general idea behind the roasting types of attacks. So, in the context of Active Directory, roasting attacks on the Kerberos protocol are based on the ability of an attacker to capture tickets which are encrypted with users or services passwords. Now, if you remember the previous video where I analyzed the Kerberos protocol, we saw that in Kerberos various messages are sent, and these messages are encrypted with different keys. Now, some of these keys are temporary session keys that are only valid for that particular session, while other messages are encrypted with long-term keys. Now, this is specifically the case for the TGS session key, which is encrypted with the client key in the ASREP message, and this is actually what's gonna target the ASREP roasting attack. So it targets this message, the ASREP message, and the TGS rep message, in which the service ticket is encrypted with the service key. And just to give you a really fast review of Kerberos, although I suggest to just go and watch the entire video about it, basically the idea is that the client first authenticates to the KDC, which generates a TGT and a session key. The client then uses the TGT and the session key to ask for a particular service ticket, and finally the client uses that service ticket to authenticate to the service and establish a proper session. So basically that's the too long didn't listen version of Kerberos. Now in this exchange specifically there are two messages that are very interesting for an attacker, and these are the ASREP message. Why is this interesting? Because it contains data, structured data, which is encrypted with the client key. If an attacker reads this message, he can try to brute force to crack the client key. In a similar way, the TGS rep message instead contains the service ticket, which is encrypted with the service key. If an attacker gets hold of this message, he is able to try and brute force the password of the service account by cracking this particular value. So basically that's the idea behind the roasting attacks. In these attacks, the scheme is the attacker reads a value that has been encrypted using a long-term secret of an account. It could be a user account or a service account, and the attacker tries to brute force what is the password of the user or of the service to be able to properly decrypt that particular session key or that particular service ticket. And so, given this overview, we can now go into the details of the ASREP roasting attack. So, the ASREP roasting targets user accounts for which Kerberos does not enforce pre-authentication. Now, this is a key thing to understand. To perform ASREP roasting, you do not need any credential whatsoever, but it only works for the user accounts for which pre-authentication is disabled. Now, why is this the case? Well, remember that to obtain a proper ticket granting ticket, the user had to send to the server a timestamp, and this timestamp had to be encrypted with a user key, so with a secret derived from the user long-term password. So basically the idea is that we have the user password. From this password we generate a secret and we use this secret to encrypt a timestamp. And the result of this computation would be used to pre-authenticate the client, which means that this will be sent in the first message, in the asrec message. The KDC would use this timestamp to perform pre-authentication, if this was configured. But of course, pre-authentication is an extra option that was not included directly in the original Kerberos specification. Therefore, if pre-authentication for a user is disabled, then there is no need to send the encrypted timestamp. And from the point of view of an attacker, this means that the attacker can just request a TGT for any user he wishes, essentially, and the KDC will not be able to authenticate the request of the attacker because we remove the encrypted timestamp. So the attacker no longer has to generate this proof of authenticity. He can just send a request without any sort of authentication. The KDC will reply with the TGT, which is encrypted with the KDC key, so with the key of the KDC, but this key is generated randomly and it's long, so it cannot really be brute forced. And also, most importantly, we find the TGS session key and other metadata encrypted with the client key. Now, the client key is obtained from the client password, right? From the client password, which means now that the attacker can use this value to actually recover the password, if the password, of course, can be brute forced, or if the password can be attacked through a dictionary attack. Now, once the attacker obtains the asrep message, the response to the authentication request, it then becomes possible to do a crack attack offline. And this is really key to understand. This attack is done offline. It means that the attacker can develop a very sophisticated infrastructure for cracking password, and it can be very, very efficient. And the Active Directory interface network, the Active Directory network, the KDC, all the components can do nothing to slow down the attacker. He can just do the attack offline. So let's try to understand a practical example. So the first thing is that we will create a specific user called asrep for this demo. So in this command, we create a new AD user and we put a simple password examp123 ! And we enable the user. So here I am in my domain controller. In my domain controller here I just, here it's not remove user, actually it is create a new user. So it's a new AD user. So I'm just gonna paste this. And this is gonna create our user. So we can get the identity of the user to make sure that we properly created it. And look at this. We have our user and we have the user principal name, which means that this user has its own identity within the context of Kerberos. So the next thing we do actually is we need to configure for this particular user, we need to disable Kerberos pre-authentication. Now, by default, in secure configurations, this is not disabled. This is actually required, which is a very good thing in terms of security. You want to have pre-authentication every time you can afford that. However, for this demo, we're going to disable it. So how do we disable it? Well, we go into the management of the users. So we do win plus R, DCA plus .msc, and we have this Active Directory users and computers. Here we have the new asrep user. And then we click into properties, into account options, and we check they do not require Kerberos pre-authentication. So properties, and once we are into the properties, we go into account. Here we will see a bunch of different options, and at the end, the last one is do not require Kerberos pre-authentication, and we click on that, and then we do apply. So the one we have to click is literally the last one in the list. And this one will determine if the user will require pre-authentication. If pre-authentication is enabled, the user in the first request, in the initial request, has to send an encrypted timestamp, which means that it's going to be pre-authenticated. If it is disabled instead, it does not have to do this. But if it's not forced to send this timestamp, it means that a malicious actor, an attacker, can require a session for that particular user without knowing the password of that user. He just has to know the user principal name, which is the user logon name, as you can see here, asrep@xstamp.lab. So basically that's the idea. Now let's check the option if we actually properly did that. So let's do this, get the user, and we're gonna select the properties does not require pre-auth. And look at this, the property is true. It means that pre-auth is disabled. So how do we actually perform this attack? Well, the idea is that it is extremely simple. So let's show it. I'm gonna open a shell down below, and then I'm gonna create a Python environment with Python 3 VM. Then we're gonna activate it and we're gonna install in Packet, which is a very useful suite of tools to interact with different network protocols in the context of Active Directory, including Kerberos, of course. Now, after we install in Packet to perform the asrep roasting to require the asrep response, we can use this script called get_npusers.py. We put the user principal name, so the syntax here is domain name / username, xstamp.lab/asrep. We put the IP address of the domain controller in this -dc-ip. This is where the KDC lives. And then we put -no pass. So we put this thing. We execute it. And once we execute it, we obtain this data. So it starts here, and this is it's all copied in this block example. And then we can actually crack it to obtain the password. Now, we can crack it using John the Ripper, using Hashcat. It doesn't really matter depending on your setup. But basically the idea is that let's just use John the Ripper here. So I have a word list of potential values. I have the ticket saved. So let's save it into the asrep.txt. So I'm just going to save exactly this thing. And then I'm just going to use this John command. And look at this. It found this password, xstamp123 ! For the asrep message of the asrep user in xstamp.lab. So basically that's the idea. We cracked the password of the account by using this message. Very simple, very effective. Of course, this can be done only on users for which pre-authentication is not enabled. Of course, notice that for performing this attack, you need to know the username that you're trying to attack. So the question on how to enumerate the usernames in Kerberos, I'll leave it for another video where we will talk about Kerberos enumeration. For now, if you know the username, and if that username, that particular user is configured without pre-authentication, you can do this attack to try and crack the password of the user. So that's the first thing. So now we can talk about Kerberoasting. Now, asrep roasting and Kerberoasting are very similar. However, they do have their differences. So basically, the idea with Kerberoasting is that this attack targets accounts that have a registered service principal name, also known as SPN. To perform Kerberoasting, we need to be properly authenticated against the Kerberos network within the context of Kerberos in the domain. If we don't have any account, we cannot perform Kerberoasting, while we could perform asrep roasting. This is because the Kerberoasting comes later in the Kerberos authentication flow. So it comes in the second set of request and response after we have properly authenticated with the authentication server of the KDC. So basically the idea is that after you obtain a ticket granting ticket, a TGT with Kerberos, you can ask for a service ticket. Now to ask for a service ticket, you need to specify the service principal name. And this is why the account you can target must have registered at least one service principal name, because every SPN has to refer to an account, to a service account within Kerberos, but also to a user account. I mean, a service account is any account with a registered service principal name. So that's the idea. And the service ticket is given back to the client. Now consider that this client is actually malicious. So what can a malicious client obtain? Well, it's a malicious client who has authenticated with proper credential, that's good. But then in the TGS rep, we see the service ticket encrypted with the service key. And this service key is a secret derived from the service account long-term password. So we have a password for the service account from which we derive the service key, which we use to encrypt the service ticket. If the attacker is able to obtain the service ticket, it is then possible to try and crack it exactly as before. So the basic attack itself is the same, it just changes what kind of password, the password of who we can get, and what do we need before performing the attack. Now, the difference between ASREP roasting and Kerberoasting, I mean, another difference is that you can disable ASREP roasting by properly requiring pre-authentication for that particular user. However, you cannot really disable Kerberoasting. Why? Because Kerberoasting is just supposed to happen like this by design. By design, the client has to receive the service ticket encrypted with the service key. And there's nothing we can configure to disable this behavior, because this is normal Kerberos behavior. It's just let's say a weakness in the exchange, and the only thing to protect against this weakness is just to use service principal names with strong passwords, which means that in general you always want to use strong passwords, right? However, if you are a service principal name, if your account has registered a service principal name, you really need a strong password. Otherwise, you can easily be attacked through this attack. Like you can easily lose the password through a Kerberoasting attack. So, notice that for this attack to work, it is needed to know the credential of a user account that can be authenticated with Kerberos. And as before, let's see a practical example. So as always, let's create a new user. This time I'm gonna call it Kerberoasting because I'm not really a creative person. So I'm just gonna call it in the name of the attack. So we have created it. We can assign to the user a service principal name. Now this is key. When we assign a service principal name to a user, we are exposing this account to a potential Kerberoasting attack. So always be careful when you do that. When you assign service principal names, only do that if you are sure that the account password is strong and cannot be cracked. So we are signing, and in this case the SPN is a simple http:/kerberoasting.examp.lab. I mean, it's just a simple string. So we have defined the SPN, so we can verify that we have properly set the SPN like this. We can get ID user, get properties, service principal name, and look at this, service principal names, we have this, http:/kerberoasting.examp.lab. Perfect. We can also use the set spn-l, so this other command. So always useful. So at this point, let's see how this attack is done in practice. And as before, we do it using the in-packet library. So we do not need to install any more packets. We already have the Python environment with in-packet installed. And specifically, the script that we will use to perform this attack is called getuserspns.py. Here we put the domain, the Active Directory domain, examp.lab, which is also the Kerberos domain. We put the username and we put the password. And we put the IP address of the domain controller. So let's execute this. Actually, let's do it on an empty screen like this. So look at this. We actually got two different entries. We got one for Leo and one for Kerberoasting. So this is because also the user Leo had a previous service principal name configured. So this is telling us that, look, we have these services of these users that we can try to attack. So we perform the attack on a specific username. So for example, in this case, we're going to perform it on the Kerberoasting user. So here it's the same command as before, but now we put the dash request dash user and we put the username Kerberoasting. So we do this. So let's open here a new tab here. We do this. Now notice what it says. It says it gives us a problem with the clock, a problem with the timing. It says clock skew too great. Why is this? This is because, remember, to perform a pre-authentication, Kerberos uses a timestamp. So the timestamp for Kerberos is really important. It is used to authenticate the different parties. Now, if when we send this message, we put a certain timestamp, so our client puts a certain timestamp, T1, and when the server receives this, it's going to read the T1, but then the server will have its own local time T2. Now, if the difference between T1 and T2, so this is the absolute difference, if it is too big, then we have a problem. So in this case, it's going to say, I cannot properly authenticate you because the time difference is just too big. This means that in these situations, we might need to synchronize our clocks with respect to the domain controller. Now, how do we do that? Well, in my case, for example, that I'm on Arch, I can just turn off the current daemon that handles the network protocol, and I can just synchronize with the domain controller network time. So here I turn off this daemon, and then I'm just gonna do nt update with -u essentially. I think this one actually requires sudo privileges, so I'm just gonna do with sudo. So it's gonna contact the domain controller and it's gonna update the local time with respect to the domain controller. So now we got 0426. So I'm not sure if it's correct. I mean, here it says 0426, but here it's not really 04. Let's try again, however. And now actually it works. So probably this is something to do with the Kerberos time, maybe in my domain controller, whatever. So even though from the UI here I see that the time is like 7 p.m., actually the Kerberos runs with this particular clock. So maybe this is something about, I'm not sure which is what, but the basic idea is that if you have time with clocks, you need to synchronize the clock on your local machine with the clock on the domain controller where the KDC is running, because the KDC will use that information to properly authenticate the user and the request. Now we obtain this thing. Now what is this thing? Well, this thing is the service ticket that is used to access this particular service principal name. And it is encrypted with the long-term password of the Kerberoasting account. Actually, it is encrypted with a secret derived from this long-term password. But we don't really care about that. What's going to happen is that in the cracking process, we're going to try many different passwords, password 1, password 2, password 3. We're going to implement the same procedure to go from the password to the secret. So from password 1, we go to secret 1. From password 2, we go to secret 2. And we're going to try to use this secret to decrypt this content. If you're able to decrypt it in a structured way, in a structured output that corresponds to what we're looking for, then we are good and we found the password. And of course, this is done automatically, so we don't really need to implement this ourselves, although it would probably be a cool exercise. But the basic idea is that once we have the ticket, so let's do it again, and let's save this ticket. It is going to be a service ticket, so st.txt, so it's a simple text file. Then once again, we can use either John the Ripper or Hashcat to properly crack it. In this case, we have to specify to John, look, the format has to be KRB5TGS, so Ticket Granting Service. This is called TGS. We put a word list with known passwords, and we put here, it's going to be called st.txt. So st.txt essentially. Let's try to use John the Ripper, see what's going to happen. And once we execute it, we immediately get the answer, which is the password of this user is xnump123. Now, of course, remember that we actually could have gotten different, the service ticket for the Leo user, right? We can do request user Leo, and we get a different service ticket, which we can also crack. Now, if we want to obtain all the possible service tickets, we can just do /request here without request user. You just do /request, and look at this, you get 2 different service ticket. The first one, which is this, it's like this one until I think here, until here, is gonna be on the Leo user, and the next one is gonna be on the Kerberoasting user. So this one and this one is 2. And we can crack them both to obtain eventually the password. Now, of course, this attack can be done only if the passwords are weak. If the passwords are weak, you are able to crack them. Otherwise, you are not. So basically, this is it for this video in which we analyze the 2 types of roasting attacks on the Kerberos protocol. Here I put a few references on the Kerberos Network Authentication Service, the official RFC, and on the previous video that I made in which I explain the Kerberos protocol, the most important aspects of the Kerberos protocol, and here we already see them in practice. How do we transfer the knowledge that we obtain from the functioning of the Kerberos protocol? Well, in these 2 practical attacks, in which a malicious actor obtains some kind of structured data encrypted with a secret derived from a password of either a client or a service, and the attacker is able to do an offline crack attack, is able to crack it offline to recover the password of either a client or a service. If you have any feedback about this video, about the topics that I explained, please write them in the comments, subscribe to the channel, and share this video and this channel with like-minded people to help me grow. Thank you very much, and to the next video.